Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 48 from the Smith Organic Chemistry textbook. And in this problem, we are asked to predict the products for a number of reactions, several different types of reactions, all of them coming from this chapter of the textbook. And so I'm just going to take them one at a time and discuss them each as briefly as possible. So for A, what we have is a carbonyl compound and a Wittig reagent. So this is going to be a Wittig reaction. And we should remember what the product of a Wittig reaction is going to look like. And so we will end up with this. And then we could show a hydrogen here as well. Right, and so that's going to be our product for A. It's the product of a Wittig reaction, so it is an alkene. So then for B, B is going to be imine formation. And so the imine that we form from these two reagents is going to look like this. Let me just get rid of these spurs here so there's no confusion. Right, and so there's our imine that we form in B. So then for C, C is going to be the formation of an acetal, or you could call it acetal protection. If you were using it as a protecting group, which is most commonly, I think, how you would see it in a synthesis. And so, of course, we're going to form that acetal. And so that's C. So then for D, what we have for D is an imine hydrolysis. And so you can think of this as cleaving the double bond and making a primary amine and the carbonyl at the position of the double bond. So in this instance, what we're going to get back is this carbonyl and how many carbons are on it? 1, 2, 3. And this primary amine. And so that's our imine hydrolysis for part D. For part E of this problem, we have an enamine formation. And so the enamine formation is going to result in this molecule, so C6H5. And I should have moved this down. I apologize. I should have started lower. Okay, so let's try again. So our enamine formation is going to look like this, with a double bond here, and our 5-membered N-containing heterocycle up here at the top. Okay, and we should note this could be E or Z, so we'll get E and Z for the stereochemistry around that double bond. But there's our enamine for E. F appears to be just a nitrile hydrolysis, and so what we end up with is the majority of the molecule is unchanged. Oops. Right. So the majority of the molecule remains unchanged, and then we've hydrolyzed our nitrile to a carboxylic acid. And so that's F. So for G, we have a hemiacetal. We're treating it with an alcohol and some acid. And so we did talk about in this chapter that's going to result in the alcohol leaving, formation of the carbocation, and then, pardon me. So the alcohol in the starting molecule is going to be protonated, and it's going to leave and form a carbocation at that carbon that can then be attacked by the alcohol that's being used as a reagent. So in this case, the ethanol, and that's going to result in essentially it's like an esterification. So the product here is going to be this with the ethoxide. All right, and then so that's G. So for H, we have an enamine hydrolysis. So H is an enamine hydrolysis. And so from an enamine hydrolysis, we're going to get back our ketone and a secondary amine. So there's the 5-membered ring. Here's our ketone. 2 methyl groups here, of course. They're not affected. And then also, as I said, we will get our secondary amine. So in this case, it is a 6-membered N-containing heterocycle. Okay, so there we go. That's H. For I, I is an acetal hydrolysis. So, of course, we're going to go from the acetal to the ketone. And so the product for I is going to look like this. There's our 6-membered ring. The methoxide over here is unaffected. And then on the other side where we had the acetal, we now have a ketone. Okay, and so that's the acetal hydrolysis. And then J, we're gonna finish with what we started this problem with. So J is another Wittig, and so we start with a carbonyl compound. We treat it with a Wittig reagent, and so basically we can just stitch those two pieces together. I will illustrate what I mean by that. So there's our 5-membered ring. And then our other piece of the molecule looks like this. And we can just connect these two by a double bond where the carbonyl formerly was. And so that's our Wittig product for J. Yeah. And so each of these is pretty straightforward. The way to approach these is just identify what type of reaction it is. And then once you know what type of reaction it is, it's pretty straightforward to determine what the products are going to be. And so that's the answer to chapter 21, problem number 48.